Hello flippers, this is video 3.1 and the unit title is stop motion animation, and the objective is I can classify triangles by angles and side lengths, and the Excel skill you should be working on is F1. Okay, let's go flippers. So what we're going to work on first is classifying triangles by angles. So the first triangle classification by angle we're going to do is an acute triangle. Okay, so an acute triangle is a triangle that has at least two angles that are smaller than 90 degrees. So here are two clear examples here. If you look at this first triangle, you can see all of these angles are smaller than 90 degrees, which makes this an acute triangle. And then the second example here, you see clearly, and I'm going to mark so that we are clear for sure, there is one right angle in the corner, but there are also two other acute angles, which makes this not just acute, but a right acute. The next type of angle we're going to look at is classifying by obtuse. So a triangle that is obtuse has one angle that's larger than 90 degrees. That will be in our picture angle C. Because angle C is larger than 90 degrees, that makes triangle ABC an obtuse triangle. The classification would be a right triangle. We have a right triangle where there's one right angle, and that is the classification for a right triangle. Right triangles are also going to be acute, very similar to the one that we saw in the classification for number 1, so just be aware of that. So now we're going to classify triangles by size. The first classification that we want to focus on is going to be scalene. Okay? So a scalene triangle is a triangle where all sides have different lengths. Here's an example of a triangle where all the side lengths are different. And we know that because none of the sides are marked with congruency symbols like you see here and here. Number 2. An isosceles triangle. An isosceles triangle is a triangle where two sides have the same length. Here is a triangle where two side lengths are exactly the same. Therefore, it's isosceles. And number 3, an equilateral. An equilateral triangle is a triangle where all sides have the same length, as indicated here. It is often the case that when you have an equilateral triangle, not often, but always the case, that it is also something called equiangular. And that means that all the angles are also the same. But remember, if you ever see a proof that asks you, is this triangle equiangular? If the triangle is equiangular, is it also going to be equilateral? That is a question we'll have to think more about. Here is our first example. It says, if the vertices of triangle ABC are A, B, and C, then classify the triangle as one of the 4. So, the first thing we want to do is draw the triangle. The points are here. A is -2, 4. B is -2, 8. And C is -5, 6. Let's graph those 3 points. Our points graphed now. Now let's connect them. Because we're classifying by side length, we need to know the measure of all 3 sides of the triangle. So we're going to do that now. And how do we figure out the measure of the sides of a triangle? We use the distance formula, or we use the Pythagorean theorem. So let's go ahead and do that. So now we figured out the distance of each side, the measure. How do we do that? Well, for BC, we looked at 2 up and 3 over. So we had 2 squared plus 3 squared equals C squared. And when we solve that, we get C equals square root of 13 or radical 13. So we'll write that in. Radical 13 for BC. For AB, we ended up with, well, you can actually just look at AB. There is no to the path to the right. It's just straight up. So it's 1, 2, 3, 4. So it is a measure of 4. For AC, we see something very familiar. It's 3 over and 2 up. So that's why we have 2 squared plus 3 squared. Hey, we just did that problem over here, which ends up being, again, radical 13. And I'm sure some of you can see right away, this means we have a triangle where we have 2 side lengths that are the same, those being BC and AC, which means this has to be isosceles. Example number 2. So example number 2 says, given J, E, and N, which are 3 points, they like us to prove that JEN, triangle JEN, is an isosceles right triangle. The first thing we need to do is graph this triangle. So let's graph it. 3 points, J -4, 1, E -2, 3, and N 2, -1. So make sure you have the right points at this point. And you want to connect them. Okay, so now we've connected them, and you may just want to look at it and go, oh, it looks like a right isosceles triangle. Well, that's not enough. We need to prove a couple of things. One, we want to prove the 2 following things. We want to prove that 2 sides of this triangle are congruent. So we want to prove that. The second thing we want to prove is that the slopes of JE and EN, these 2 segments, are opposite reciprocal. And if you don't remember what opposite reciprocal means, it pretty much means if one of the slopes is 1/2, the other one will be flip it and negate it, -2. So we're trying to look for a situation like that. And if we find that, that means those lines are perpendicular, which means that those 2 segments then meet at a right angle. Okay? So here we go. First things first, let's prove that 2 sides are congruent. And if we look at this picture, I'm going to aim and bet that JE is going to be congruent to EN. Let's try and see if we can prove that by using the distance formula to find the distance of each side. So here we found the measure of the side JE by looking at the 2 squared plus 4 squared to give us C squared, which is JE. And JE ends up being radical 20. We've done the same thing for the measure of NE here, where we've looked at 2 squared plus 4 squared equals C squared, which is EN, which also gave us radical 20. So we proved our first part in this, which is that we have 2 sides that are congruent. So let's go ahead and mark them. JE is congruent to EN. So far we know this definitely is an isosceles triangle. Now let's prove it's right. Here now we've determined what the slope is for JE and for NE. And that's what we actually need to do to figure out if they are indeed perpendicular lines. So here is the slope of JE. And we found this by using, again, the markings that we'd already used, this right triangle we used to create before. So JE slope is -4 because you have to fall 4 and go forward 2. And that actually simplifies to -2. So that's our slope of JE. The slope of NE is you actually fall 2 and go back 4. So that's -2 over -4, which simplifies to 2, 4. And if we take those 2 numbers, -2, and at this point, before we multiply these 2 slopes, -2 and 2/4, let's just reduce this slope over here, 2/4, to 1/2, because those are equivalent. You're going to see why in a moment we need to do that. Okay, let's go back to it. So now let's take again -2, we've got it here. And if we multiply that by 1/2, we're going to end up with -1. Yes! And that's what we wanted. Remember, because if that happens, that means that these 2 lines, segments, are perpendicular, and that means this is a right angle. So now we've actually proved that with these 2 things. The secret hot question tonight is, triangle ABC has vertices, and those vertices are 0, 0 for A, B is 3, 2, and C is 0, 4. This triangle may be classified as a what? 1, 2, 3, and 4. Please be sure that when we look in your interactive notebooks that we've seen you graph this. Okay, that's a part of the WISC. That's a part of the secret hot question. Do not randomly pick one of these choices because that is not actually doing the work. Please make sure you do that. We'll be looking for it when we check your notebooks tomorrow in class. Also, remember to work on that Excel skill, F1. Have a great day.